Normally, Csrf is included in libraries like Flask WT forms, which don't work in Qt since they use the Flask request object. So we'll do a quick implementation for it. We'll generate a UUID and store it in the session, and then check that the token on the form matches it. We'll then check that the username hasn't been used earlier. Finally, before we register the user, we don't want to store clear passwords. Normally, I would use Workzoid, but Qt doesn't include it. So we'll install the Passlip library. So let's install Passlip first by doing poetry add Passlip. The first thing we'll do is check that the username being sent in the form hasn't been taken by another user before we save it in the database. We're going to grab the database connection that we have in the application context. Then we build a query using the select method from SQL Alchemy. The select has a where clause to match records that have the same username. We now send the query to the connection using the fetch1 method, since we only need one record to hit for the username to be found. We then check if a row is set. If it is, that means there is a user in the database with the same username, and so we set an error for us to stop the operation. Notice, however, we don't have any error checks in the code below that. We're just checking if the username and password have been set. So I'm going to move that check all the way to the top, right below where we fetch the values from the form, and then create the not error section, which is where we will save the user if no errors were found. There's one more thing. Notice the squiggly line we have in line 20? It's a bit misleading, but if we hover over the error, you'll notice it says Qt has no attribute DBC. This is a complicated issue to solve because the linter can't see we've added this DBC property to the context, and there are ways to solve this using some convoluted ways, but since I know this is not a real error, I will add the following comment so that the type checker ignores this error. Okay, now we're ready to save the user record. Let's add the hasher we'll use from the Passlip library and create a hash from the password string. This hash will be stored in the database instead of the actual password string, and not even us will be able to tell what the password string is. We then create a SQL Alchemy insert statement, send it to the database connection, and then commit it so that the record is actually created. Let's now run the application using the debugger to see if things are working correctly. I will put a breakpoint on line 25 and run the application. I will go to the localhost 5000 register URL and enter a username and password. I can now see the application is stopped on line 25 and we can step through line by line. If we now see the row after the fetch1 operation, we can see that it is a non-value on the debug console. If we continue stepping, we can see that the execution enters the if not error section, since no user record was found in the database with that username. Let's take a quick look at the hash. As you can see, it's a very long and random string generated by the Passlip module, which is what we want. Now let's check the query statement being generated by the SQL Alchemy insert. We need to cast this as a string, so we use str parentheses statement to check it out. As you can see, it's a proper SQL insert statement. So let's resume the debugger so that the code finishes running. We should have our first user record in the Docker instance. Let's go ahead and double check that. Open a new terminal and type the following command: docker exec -it app db1 psql -u app user app. This is executing an interactive pSQL command on the Postgres container called appdb1 using the app user on the app database. We can now see the list of the database with \l and see the app database there. Let's connect to the app database, so we issue \c app. Now we can see the contents of the user table by doing select star from user . We need to surround the table name user in double quotes because otherwise we get the internal PostgreSQL current user. As you can see, we get the record with the ID, username, and password hash, so that's great news. Now let's try registering another user with the same username. If we now debug line by line, we can see that row now returns a record, and if we check the username, we get the existing user's username. If we continue, we'll see the application now sets an error message, and if we continue, we'll see the error on the form. Perfect. Now let's work on the Csrf component. For this, we'll need the UUID library that will generate a random timestamp string for us. So first, let's generate the Csrf token using the UUID generator. This will be a new token every time we hit the URL. Next, we check if the request method is a get. If that's the case, this is the first hit, i.e. when we're rendering the form. So we'll set a session cookie with the name Csrf token. That way, when we get the post from the form, we can check if it's equal to the one we have from the initial render. Remember to add the session module to our imports from Quart. We also need to pass this Csrf token to the templates context. This value will need to be added to the form as a hidden input. So let's add it to the form like this. Save the file. Now let's run the application to see if the form has the new Csrf token in it. We go to the register page and view the source. As you can see, the hidden field is now in the form properly set. Okay, this is the last step. We now need to check if the token value stored in the session we set on the initial render matches the one being sent by the form. If it's not, this means a hacker is trying to make a post from a server other than ours. So we just throw an error message. Finally, if there are no errors, we delete the session token so that we don't have it around. And if there was an error, we need to reset the session token to the one we just generated in this new request. Save the file. Now let's run the application and register a new user. Looks like everything worked. If we check on the database, we'll see the new user is in the database. And now let's try to register a new user that's being sent by a hacker and modify the Csrf token on the form by editing the HTML. When we post this form, we get the invalid post contents error, which is what we want. Congratulations! Now we have a registered form with Csrf protection that can now be used to register users. In the next lesson, we'll see how we can log in to the application.